repeating, okay? What's here in photodiodes, what we are doing? Listen here. So this is PN junction diode. This is P type. This is P type. Okay, this is P side and this is N side. Okay, and this is negative and positive. See, this region here, what happens? There are in P type material, majority are in P type material, majority are holes. Very good. And minority are
atoms. No, wait, sorry, electrons.
Yeah, minority are electrons. Very good. Very good. Now, what about N type material? Majority
Electrons.
are very good. Majority are electrons and minority are
Holes.
holes. Very good. So minority are holes. So what will happen? When this area, this is a depletion region. Okay, the depletion region is made opaque. Opaque is transparent. Is it meaning same?
No, sir.
Opaque is different, right?
Opaque
It
means
block
full zero.
block. Yeah, at least you know that, huh? So opaque.
Sir, I told about P and N.
Yeah. Very
Sir,
good.
I told about
It's
what
okay.
you said.
So this region,
I remember what you said.
please record it. So this region is transparent region. So what will happen when the light incidents on this one? So electron hole recombination takes place. But when the electron hole recombination takes place, we have to give the direction for the electron and holes to move in one particular direction. Is it not? Otherwise, they will go here and there. For that, we need a proper biasing also. So what we have done here is we have just connected a potential difference. Why? Only just to make positive negative. This is nowhere conducting the electrons. When light incidents here, what happens? It gets enough energy. The electrons and holes will get enough energy. Then what happens? Electrons will go and sit in the place of holes. That means electron hole recombination takes place. Due to the
Sir, which one is the hole, the middle one?
This is the hole and these are the electrons. Here also these are the holes. Okay, hole is nothing but
okay.
vacancy part of electron. Like this chair is empty, man. This is a hole. Okay, when he moves here, then automatically when electron moves in one direction, hole move in the opposite direction. Actually, holes are not moving, but they are vacancy created by the electron. Is that clear? So electrons and holes move in opposite direction. So what will happen here? See, P and N is there. Then what will happen? This is we are just connecting this only to develop potential, to make one positive and negative, only for that purpose, not for the flow of electrons. So what happens when electron hole recombination takes place? Electrons start flowing in one direction. See what happens if you see this properly. This is positive and this is negative, right? This is negative. So what happens? Electrons start flowing from negative to positive. Is that clear?
Yeah.
So that is how you can see the deflection in microammeter. Is it clear?
Yes.
Is this clear? Now you may ask me, sir, where we are using. I will give a simple example in optical fiber communication. Sound energy is converted to electrical energy. Electrical energy is converted to optical energy, and through optical fiber OFC, optical fiber communication. So what will happen? Optical energy is converted to electrical energy. Then electrical energy is converted to electrical to optical. Then here sound energy. See, when we are talking on the landline phone or something, here in this lab we are using a landline phone. So we are talking on the phone. Okay, to your friend Abdul. So sound energy is converted to electrical energy. That electrical energy is converted to optical energy. And there is optical fiber. If you see that modem box, there's a yellow color wire. In that there is optical fiber. That optical fiber cable. Okay, that through that laser light will pass and it will reach the destination somewhere in Abu Dhabi. Then optical energy is converted to electrical energy. Then electrical to electrical energy to sound energy. Is that clear? Optical energy, electrical energy, sound energy. So the whole process takes only 10 to the power of -9 seconds, 1 nanosecond. Can you understand now? That's how fast is our technology, 1 nanosecond. Now,
Sir, it's not EO.
means, optical energy. Optical energy to electrical. So here what we can write here, we can write laser light. We can use injection laser. They'll use a laser. Okay, laser in the optical fiber. Or we can use LED, light emitting diode. Here, this is the source. These two are sources. Sources for optical fiber communication. Okay, and here we need a detector. Okay, what are the detectors now? We can use PIN photodiode. PIN photodiode. Okay, P insulated N type photodiode. So this is a sensor actually, or detector. Is it clear? So we are using photodiode is mostly used as a detector, and LED is used as LED. This is used as a detector. This is used as a source. And solar cell is converting light energy into solar energy into electrical energy. Is converting solar to electrical. Is that clear? Solar energy to electrical energy. Is that clear? It's clear? Sure. So now here, this is the way it is converted. Now what we have done, is it in forward bias or reverse bias?
reverse.
Very good. So P is connected to negative, N is connected to positive. Then that is reverse bias. So what is happening now? We will draw the reverse bias characteristics. In reverse bias characteristics, we have this is microampere, that is current in microamperes, and this is voltage, potential difference in volts. Now what happened is we are taking the intensity of light. This is I1. So we have three intensity. I are taking four intensities: I1, I2, I3, and I4. Four intensity. The first intensity let it be 1 watt. What is what? What is for power? Is that clear? So 1 watt, 2 watt, 3 watt, and 4 watt. Is that clear? Okay. Now, means like we have bulbs, no? Like if you take 20 watt bulb, the brightness is thick. That not that much. 100 watt, more brightness. So we are using the brightness of light here. We are using here brightness of light here. Okay. Is that clear? So I'm using first 1 watt I'm using. Then 2 watt. Then so for 1 watt, the intensity is like this. This is the reverse bias characteristics. But this is for 2 watts. Okay. This is for the second one. This is for 2 watts. This is for 3 watts. This is for 4 watts. Okay. Is that clear? This is I2, I3, and this is I4. Is that clear? I1,
Yes, sir.
I3, and I4. Is that clear, Ruti?
So can I?
Uttar thing.
Yes, sir.
Yeah. So this is the VI characteristic. Means you can see here if the brightness is more, then the energy is more. Why? Because power is directly proportional to energy. Is that clear? Power is directly proportional to energy. More power, more energy. So it emits more energy on this one, incidents more energy. So more electron hole recombination takes place and flow will be more. So that is the reason we have reverse bias. These are the characteristics. Is that clear?
Yes, sir.
Understood? So I'll send you the notes for all the remaining chapters also. Okay, I'm organizing everything.
So can I write this?
Okay, please copy this one. Copy this, then we'll go ahead.
This,